live. Actually, I need one more thing to do, which is this video that I made. Put that, and I'll just put that in first. The ReaFIR video player won't be laggy if it is. Oh man, I guess I should show you my screen now. Where did that sound come from? With respect, JSFX. Looks like we are live. Despite the fact that we're live, everybody's muted. What the fuck? Alright. What the fuck? Alright. Streaming with a guest. Here we are. Hello, everybody. How's it going? Welcome to episode, I don't even know, 14 or 15 or 13 of JSFX Scripting for Beginners. And like we did last week, we are making a we're making a gravity-based delay. And as always, I have with me the awesome Leandro Facchinetti. Hi, Leandro.
Hello, Aria. Thanks for having me. Looking forward to actually putting some graphics into this effect.
Yeah. So that is the order of business for today, because I think our like the sound part of stuff is more or less in order. We may need to like optimize parameters and stuff like that. And for that, you told me to make a video of a bouncing ball thingamajig, which I did. And I made it, well, I did one where we can kind of read the meters, but I don't know how good I did that. I'm not a videographer, so it was hard. My lighting was kind of crap. So we'll hopefully be able to kind of make out what's happening. Why do you do this? Undock. Yeah. So yes, I have a ball, and also in my I got a meter from Amazon, but instead of being in meters like normal people use, it was like in inches. So I went with close to, I think, 41 inches. It's about a meter, okay, give or take a few centimeters, and give or take my error of actually releasing the ball from exactly where the 1 meter mark is.
I think we're going to do it the same way that all of us used to do it in our physics lab university. We're going to fudge the data a little bit to get the results we want.
Yeah, exactly. So yeah, I will see it in 3 speeds, because I did record it at 120 frames per second with this cool camera. Oh, sorry. I'm getting complaints that my bitrate is lower than recommended. So if anybody is watching, let us know if things are weird sounding, okay? Yes, please let us know if things are looking or sounding weird. And I am going to hit the video. And take 10. I think that was the ticket. That was the ticket. What? And then we'll see slower.
What?
One thing that stands out to me is that this takes surprisingly longer than I would expect for the ball to stop kicking.
So this is a quarter speed.
Cool, we have a lot to work with. So the theory here is that the mass of the ball does not matter because gravity is going to pull something that is heavy or something that is light in about the same, well, I want to say velocity, not velocity, acceleration. Yes, the acceleration of gravity is going to be the same. So if we get the height right, in our plugin we have control over the height and we have control over the bounciness of the ball, what we are calling the elasticity of the ball, how much energy the ball is going to lose in terms of sound and how much of it is going to be for the ball to bounce back. So if we get the height right, and if we tweak the bounciness of the ball so that the first kick is in the right place, then if we got our physics right, then everything else is going to match. That's the promise, I think. Is that right?
Yeah, more or less. We're gonna take some liberties, obviously, and like we're not taking into account like friction. You know, the whole city of Montreal is crooked, and I pretty much confirmed that, like, because I was really just letting the ball go, and it would just go bounce, and then it would move like to the other end of the room, and every time it would go in the same direction. Even when I like nudged it slightly in the opposite direction, it was slowly bounce towards one of the walls. So I'm like, yeah.
Okay.
Yeah. So like, yeah, those factors aside, I guess human error aside, yes, that's the basic idea. I would love for us to be able to also have a way of like BPM syncing each bounce. So like essentially quantizing each bounce to like the nearest 30 seconds or possibly to the nearest like triplet eighth or whatever. That would be a dream.
So are you saying the first bounce would match a certain point in time, or?
All the bounces, if possible. You know what I mean? So like the first bounce and the second bounce would be a half note apart. Then second bounce and third bounce would be a dotted quarter apart. Then third and fourth a quarter. Then like half dotted, and then it keeps kind of going down in that in like a more or less quantized way. That would be really cool.
I think that does not respect the laws of physics,
not at all.
Right? Because okay. So that's a different mode of operation that is not exactly modeling any kind of. Well, we would not be using the equations of motion we have been using so far, right?
Okay. So that would be like a whole other thing, basically.
Yeah, the principle is the same. We would have a delay line and a bunch of taps, and we would need to calculate the taps based on some equations. But right now we are using the equations of motion to calculate the taps. In other words, we are simulating a ball drop using mathematics, and we are getting the time when the ball is falling on the desk, and that's the time of our tap. We adjust the time of our tap to be that. But if you want the time of the taps to be quarter note and a dotted quarter note and so forth, then, well, I don't think you can do that using the same equations. I'm not entirely sure about this, but as far as I understand, the equations of motion are going to be in such a way that even if you tweak the gravity, if you tweak the height, the initial height, and even if you tweak the bounciness of the ball, it is still not going to respect anything.
Yeah, anything
musical.
Exactly.
In most cases, we would want things to be multiples, sort of. So we would want the second bounce to be half the time of the first one, or something like that, or 1/3, or something like that. And I don't think that it's going to pan out using the same equations.
Yeah.
But we could have a different mode of operation that would be more musical.
Yeah.
And less physically accurate.
Exactly. Bo says, before you get started, could Leandro explain how you set up a different IDE for ReaFIR? I don't think you do that. Do you do that?
Sure. Yeah, I usually don't code using the built-in IDE in ReaFIR. I don't find it super comfortable. So there are three flavors of scripting. There are ReaFIR scripts, then JSFX and video processors.
Oh, but I think what Bo means is that if I grab a thing like let's grab an xrame script. How do I have 0 xrame scripts? Are you kidding me? There we go. Oh, it's because it's x-rame. I think what he's talking about is like when you open this, for this to go and open in Visual Studio Code. But you don't do that, do you?
No, I manually go in Visual Studio Code and reopen the same file.
That's what you mean, right, Bo?
Yeah, you usually don't see me doing that. I do it before the stream, but if necessary, yeah, that's what I do. I open the same file in both ReaFIR and Visual Studio Code. But one thing that I was going to say is that when I'm doing video processors, I tend to use the built-in IDE because a video processor doesn't really have a file, just a setting on the video processor effect. So it becomes more annoying. The way I would do that, and sometimes I do it when I need to do some more careful search and replace kind of thing, is just I copy and paste the code from the video processor into Visual Studio Code and then back. It's not super ergonomic. That's why I tend not to do it. But it is what it is. And if you click on that little open in external editor button, as far as I can tell, you cannot change which editor that is going to be. It's always opening on the default editor for your operating system. So that would be TextEdit on Mac and probably Notepad on a PC. And I don't find that very useful because those are not the text editors I tend to use. So I don't click on the button.
Like to change this, there is a really kind of crazy thing you can do, which is, I found it in the forums, and that's like to modify the .ini, the ReaFIR.ini, because there is a line in there that says like open in TextEdit, and you go and change that. But I don't think you should bother with that because it seems like so crazy convoluted, and the kind of like another thing you can really do quite easily is just go to the directory and open it. I guess what would be a nice thing for them to kind of add, which I don't think right now exists, is like right-clicking here and going like show effect in Explorer Finder. That'd be nice, just so you're like a couple of clicks away. But for me, in my Finder, I have my ReaFIR resource path. So a couple of clicks, open it with whatever application you want. Don't edit .ini because not that will like break anything, but it just seemed like as I was reading like how to do it, it seemed like definitely not worth setting up for me personally.
I am not afraid of diving into the INI file. It's just a simple text file.
Yeah, like I mean, I'm not
like, looking at it right now.
I'm not afraid of it. I'm just like, I actually like, even when I go to Visual Studio Code, it gets harder for me because for me at least, like the colors of the ReaFIR IDE mean things, and without them I'm kind of lost.
Fair. There are extensions for Lua when you're writing ReaFIR scripts, and for JSFX as well. And I suppose that the video processor, because it's using the same language, the extension would work just as well. I don't use it myself. I just go with no colors, and that's fine by me, but whatever. Whatever floats our boat.
Shift. All right. Yeah. So, all right. So I'm gonna remove this 2-pop synth, and I'm going to open our delay, which is somewhere. It's here. And I'm gonna go to edit, and here we are.
Okay, so, well, I think that we want actually to play with the sliders and play with some sounds. Specifically, what we want to do is to have one sound, just a click, going through the effect. And I think you have that already. There you go. And the height, I think that you dropped the ball from 1 meter, so we don't have to change that. And the gravity, we don't have to change because you were on Earth. And then there is just the elasticity, which is going to determine the second bounce. So how about we run that and print the result so we can see it. And then we try to align the first bounce with the measurement, the video that we recorded. And then we play around with the elasticity, trying to get the first one right and see how the rest goes.
Yeah, from having done tests before, I can tell you that it just doesn't bounce as many times as it's supposed to. It dies off quickly, and I think that's actually not the physics part. That's the amplitude part. So our thing decays in amplitude real quick. And if we look over here, what I find super interesting is that there always seems to be a little bit of an increase on the third bounce. So it goes bounce, less, more, less, goes down. Then there's always another one as well. I just find that interesting. And that could, again, be like, I don't know, uneven surfaces, and it hits like the side of the wood instead of the center of the wood or whatever. But I just found that interesting because I did 10 takes of it, and in every single take, 3 was louder than 2. Yeah, so anyway, that I found super duper interesting. Let's run and print this. I'm actually using an actual ping pong ball instead of a click. Do you want me to go and like make an actual like burst of?
I don't care.
Yeah.
The ping pong ball may be even better. So yeah, we can tell that that is definitely dying off quickly. But there is another magic number in the code that we don't have a slider for, and maybe we could have a slider just so it is easier to play around with it. That's the value that we use to compute how much sound to produce based on the velocity of the ball as it hits the table. And I think that's the one. Yeah, that one. Yeah, we can turn that into a slider, and then it's going to be easier for us to just play around and find a value that makes sense.
Cool. Sounds good. I'm going to do that real quick. My computer's being all like, and I want to kill somebody. Sound decay. I guess, I don't know, the range. Let's go for like, I guess the default 2. And let's go from like 0.01 to, I mean, I doubt we're going to go more than 5, right? What do you think?
If I remember correctly, this is a variable that the lower the smaller the number is, the louder sound we get. I forget, but I think that's how you used it.
I think so,
and
too.
In that case, we probably don't want to go higher than 2. We probably want to go lower, but I forget. I may be misremembering this.
I'm going to set it to 3, and we will, I guess we'll play with it now. So in order to do that,
oh, you definitely want to remove the line that reads sound decay equals to 2 below. Otherwise, the slider will keep resetting.
I'm going to comment it out. And let's save Maru. And okay, so the way I'm going to do this, I guess, I'm just going to make a bunch of copies of this. And then what we can do is, fuck, why can't I talk today? It's because I'm trying to do stuff without or while talking, and I just can't do that. I'm an idiot. All right, this is why my live streams that I mix all sound super idiotic, and then I'll just play with this result until we get a thingamajig. Oh, you see? So at 0.5, the second bounce did get louder. All right, so I guess we're going positive. All right, wait. Hold the phone. We need a longer thing. Oops.
You could just loop.
Well, yeah, but you need the file to be longer to loop the longer thing.
No, I meant you could put markers and loop in ReaFIR.
Oh, I mean, that doesn't make a difference if this delay is still going, like your plugin is live when you go to the beginning, you're still getting, because what we were getting was like the delay from this one wasn't dying and the next one was starting.
Yeah.
That's actually pretty good, realistic. It's weird that it's... Why didn't it respect the range that I asked for? Did you notice that?
No, I did not. What happened? In fact, we don't have that new slider. We have 4 sliders in the code and only 3 on the screen.
I'm touching the wrong thing. You're right. Maybe it's because of this. Let me call this magic number.
Okay, but that should not affect. You could have, you should be able to have multiple sliders with the same label. So I suppose you are editing the effect on one track and you have the effect on another track, and then it's not picking up. If you have the same effect in multiple tracks and you edit one instance, the other instances don't necessarily reload.
Mm-hmm. Yeah. Okay. So fixed now. So this is with our number at 2. Let's decrease the number. Let's set it to 1. I'm still pausing and playing anyway. I didn't feel a difference. Did you?
I did not.
Did not. Wowzers. Did you hear that?
Yes, that became very loud. So yeah, I remember correctly, the smaller the number, the louder the sound. And I think that we now have a good range. Between 2 and 0.1, there is our sweet spot.
Yeah. Wait, where did you get 0.1?
You used 0.1 and then it became so loud that it auto-muted.
Oh, yeah. Oh, but I'm saying, so then let's maybe go from like 0.5. Or something.
Yeah, sure.
And then I'll make this smaller. Sorry, give me a second. My cat she's got things to say. 1 sec.
Sure. And meanwhile, we have Altolectuals. Hey, Altolectuals. Great to have you here. And yes, what we are trying to do is a ping pong delay for real with a ping pong ball. It's a completely different concept. It's not bouncing from left to right. It's just the taps on the delay are timed to resemble a ping pong ball falling on a desk. And that sort of sounds cool, especially when it almost turns into a pitch because the taps become very short at the end.
Yes. Oh, Aryan in the house. What up, my glib glob? Aryan is an old friend of mine. He's not old. We're just friends for a long time. Yes, I always thought ping pong delay was named in a confusing way. Should have been called tennis delay, and then real ping pong delay goes bounce, 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 bounce. Okay, so Leandro. All right. Let's see. I guess I'm full recompiling and resetting, checking that the range is Gucci, muting my master. Let's try one more time. I guess let's try it with 0.5. It's still the same number of bounces, but the second bounce is just obnoxious.
Oh, yeah. So there are 2 different variables at play here. One is the elasticity. That is going to determine when the bounces are going to happen and how many of them are going to happen, which I guess is a consequence of when, right? And that's the elasticity. That's how much energy of the ball is being translated into sound and how much of it is being used to bounce back. That's the elasticity. The magic number determines how much sound the ball produces when it falls on the desk. So it's going to reach the desk with a certain velocity, which is determined by the gravity and also by the elasticity, because if a lot of the energy is going into bouncing the ball back, it is going to hit the desk at a higher velocity when it comes back.
Yeah.
But that's just when the bounces are going to happen, how many of them are going to happen. The magic number is going to say, okay, now that this bounce happened at a certain velocity, how much does that translate into sound? And maybe, probably, there is some kind of physics equation we could use to relate elasticity and the magic number. In fact, I think that they are related. There is probably some kind of factor of the material, because if the thing that is hitting the desk is kind of soft, I think that it will make less sound, and if it's harder, I think it's going to make a louder sound, but I'm not sure. I'm not a physicist. In any case, I think there is some equation to relate the two, but we are trying to tune this by hand because we don't know the equations. So that's what we are doing here.
So at 1, it feels insanely identical to 2. Just looking at the meters, I'm hearing 4 bounces. It's going to clip. I mean, also, like, we do have a hard clipper on the master track, so everybody in the chat can keep their panties on. Nothing's going to, like...
Yeah, but Ari, what I'm saying is that you just changed the magic number. That's not going to change the number of bounces. It's not going to change the timing of the bounces. That's the elasticity. The elasticity would change that. The magic number is only going to change the levels of the bounce. So you can see that now it's actually clipping when on the second bounce, which doesn't really make sense, right? You're bouncing up that ping pong ball. You're not putting more energy into the system, so it shouldn't be getting louder. It should be only getting quieter.
Okay, so I'm changing the elasticity then. Well, there we go. At 0.9 something interesting happens. I want to... we need a longer one. All right. I'm going to just stop
that sounds more realistic to me.
Yeah. That's pretty fucking realistic. Yeah. One thing that...
It is very good.
One thing I find really weird is that the distance between the first bounce, which is the dry, and the second bounce is really bad. And then after that, it gets really good. Did you notice that? It goes ta 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 ta. You know what I mean?
Yeah, we could look into that. That may be a bug somewhere.
Kimian law can... Oh, I thought you're gonna tell us Kimian law is what we need to look into, but okay. I'm using this in one of my songs, and that's why we thought to make a JSFX for it. Ariane. That's pretty incredible. I'm really loving how that's sounding.
Especially because we made it with mathematics, with our bare hands. Yeah. I mean, it feels so good.
Yeah, that's really good. So I guess...
Oh, you know what I want to play with real quick? If it is easy... No, don't let it be 1. Because, well, it's not the end of the world. But if the elasticity is 1, that means that the ball is not losing any energy when it hits the desk. In effect, it's like 100% feedback on a delay. It's going to sound forever. It's not a big deal because we are not getting any louder or anything, but it's just going to bounce forever.
So why do we clip? Why do we clip? Yeah.
Because of the magic number. We need to change the magic number.
Okay. So should I set... I'm going to... What if I also make this 0.99?
Yeah, if you make it 0.99, then it's going to really take a long time for it to stabilize. Yeah. But that at least makes sense. It's not going to ring forever, not something. It's not going to ring forever that way.
Okay. So I guess we're tuning the magic number now.
Yeah, that will tune the loudness.
Okay,
Yeah.
let's go 1.6. My master is muted. Okay. I mean, other than that first clip, that sounds reasonable. But I guess we're avoiding that first clip. Yeah, something happens on the second one. Then it kind of gets... No, I lied. This one stayed kind of toxic the whole time. Yeah, but why would it self-oscillate at the beginning when the delays are far apart? We really want it to self-oscillate at the end.
Yeah, I don't know why the first step is kind of weird. We could look into that. I mean, I'm sure there is a special case in the code. I remember when we wrote the code, the first bounce is special
Indeed.
because we don't know the velocity with which it's going to hit the desk. So we calculate the first bounce specially. And then from then on out, for all the other tabs, it's the same loop. But for the first one, it's special. So maybe there's a bug somewhere in that part of the code. And that's why the first bounce sounds
Yeah,
weird.
and on the magic
That could make
number
sense.
at 2.6, we're no longer clipping, but the second bounce is still louder than the first bounce. You want to hear it?
Yeah, and yeah, sure. And another thing is, we are now using the magic number as a multiplier. We're just saying that, in other words, we are saying that the loudness of the sound is directly proportional to the velocity of the ball.
Yeah.
But I don't know the physics of this. This may be wrong. Maybe the loudness of the sound is proportional to the square of the velocity or the square root of the velocity or some other relation that is not linear. So our magic number is never going to get it right. Maybe. I don't know. We could look into that. If we can tune something that sounds okay, I think we can go with that. Otherwise, we can try to look it up. Maybe we can find something, or maybe we can come up with our own curve that we think sounds nice.
So I guess I know one thing about this from when I was first toying with this idea. I may not have there's no footage of it, but I recorded sound when I was trying to make this with RIA delay. So if you drop something from a further distance versus like a shorter distance, one thing I found that happens that's really cool, and I mean, we don't have to get into coding that part for this delay because that gets insane, is that the loudness changes very minimally, but the frequency content changes insanely. So like the difference between 2 meters and 1 meter is in frequency content. The higher up you are, that first transient is like more on the high end. It's like versus, and you can see this if you watch like ping pong, you can feel that as well. Like when they're just kind of softly passing it on to each other, it goes pa pa, and then when you go really hard, it goes ta. It just has that like to it. We don't need to code this bit.
Well, we could. It could be interesting. One of the things that people put in delays is frequency shifting, and that's what we are talking about. So we could do a frequency shifter based on the velocity instead of just this loudness.
And like, yeah, indirectly affecting the loudness. Bo has an idea which I'm down to try, which is to do a spectral analyzer. Actually, doing spectral analysis on MP4 takes a super long time for no reason, so I'm going to do this. I'm going to glue it to audio.
Yeah, in general, my word of advice is don't load lossy formats into ReaFIR. ReaFIR doesn't like them.
Okay, here we go. This actually doesn't have the resolution that I would like to see in it, so I'm also going to go mono. Mono, I said, oh, my computer is just being slightly slow, and it's enough to make me lose my absolute shit over it. Okay, here we go. And why are you kind of pale? Don't be pale. Give me that. Give me the good stuff. Boo boo boo. I guess we are more interested in frequency. Just give me a bright. Yeah, all right, that's bright enough.
Is this the real recording, or is this the recording from our delay?
We can look at our recording from our delay too if you want. Once I find.
Well, our delay is not going to be interesting. It's not doing anything to the frequency.
True.
It's just
so
replaying
it's
the
just
sound.
Gonna be
we
the
know
same
that.
as the first thing.
Yeah.
I mean, I don't see actually much. I see some shift. And it's actually a very cyclical shift. So it goes up, and it goes down, and it goes down, and it goes up, and it goes down, and it goes slightly up. You see that as well?
Yes. I see what you mean. I mean, that and the loudness that you noticed before is something that we can encode into our plugin rather straightforwardly. It wouldn't be too hard. All we got to do is when we are computing the next velocity based on the previous velocity and the elasticity, you can just throw a random number in there. A very small one, probably, but that would make the next bounce go a little bit higher or a little bit lower, and that's going to translate into more sound and even some frequency changes if we implement the frequency shifting thing.
That sounds fun.
That's something we can do.
Should we get in the code?
Yeah, sure, we can do that real quick. It doesn't take that much to do it. All you got to do is just find the portion of the code in the slider block where we are computing the next bounces. That's the loop that you have right there on the screen. And we do have a line that reads velocity times equal elasticity. You can just put a random number in there, but a very small one probably.
You're talking about this line?
I'm talking about this line, and you can say elasticity plus, and then rand. RAND, that's the function for calling, generating a random number, but that number is going to be between 0 and 1, so that's too much. Divide that by a number. Divide that by, like, I don't know, 100.
Okay.
I don't know, something like that.
So
or 10, if you want to make the effects very drastic.
This, right?
Something like that, and that's going to give us a small number, but this number is always positive because the initial number was between 0 and 1, so now we are going between 0 and 0.01. But we do want the randomness to go to one way or the other, right?
Minus a half.
So how about we minus half of that value? So minus half of 100th.
Yeah. Like this.
Oh, so if you want to do it like this, then that's fine. Just subtract before you divide.
So rand minus half. I see, yeah. Rand minus half divided by 100. Forget about this. Shabloinks.
There you go, yeah.
To what end are we doing this? Like, why are we going random?
Because that is going to determine the next velocity. So that is modeling this random value that we're putting there is modeling the fact that imperfections on the ball or on the surface, or maybe the distance from the microphone. If you think about the taps as just putting a microphone on a ping pong ball, the distance from the microphone is also going to determine the sound. So we are modeling all this variation using this random number.
I guess I should say in the video I have a mic on the floor. So it is always the same distance to the ball hitting. Well, it's not the same distance because it may have moved in other axes, but at least it's always on the same height in relation to ground zero. Okay. So let's check it out.
Yeah.
All right. And well, yeah, I mean, I love this every time.
It would be hard for me to tell if the randomness was well tuned, because if you get the randomness too small, then it's not going to make any difference, and if we get it too big, it is going to sound too crazy.
Yeah.
So we need to tune that parameter. And I just said 100, but I don't know. So we need to look at the waveform and see if we see some variation. That's good. And if we don't see too much variation, that would be bad.
I don't see almost any. I see it fully linearly going down.
So maybe put another slider for that, and we can tune that one as well.
So I'm going to, I guess, take this line and put it above. Ugh.
I don't think you need to change the whole thing. Just change the 100.
Oh, but I thought you want to make this a slider.
Yeah, say that. Yeah, just the 100 needs to be a slider because the rand minus a half, that stays fixed. We are just getting a random number. Now we are scaling the random number.
So I'm going to call this random divider, and I'll make this a slider. Just going to type it this time, random divider, source survivor. I guess we can random divide by 0, so I'll go 1, and I'll go to 200, and I'll go to, I guess 1 to 1000. Well, we already know 100 is not enough, so I'm just going to go 100. And let's go, we don't even need fine numbers, right? That is the random divider. I'm going to go random divider. Did I miss any syntax?
Yes.
No, I did not. Full recompile reset. Goodbye. Motherfucker with this thing. Alright, I just gotta add it. That's why I added a hotkey. There we go. Okay, so random divider was 100. Let's go 50. Okay,
Yeah.
I'm gonna keep this recording. Shabloinks. Oh, too soon.
Yeah, that's the other thing. If we have a number that is, if we have a random number that is too random, it is going to affect the velocity too much. But remember that the previous velocity is going to affect all the next ones. So if we get one that is too quiet, then it's going to die off. So that's why it's important to tune this parameter very carefully.
Cool. I'm just doing the thingamajig like suchly. And let's just... So I now went to 75 from 50. Too soon. Gone too soon.
Are the rest of the parameters in the right locations? The elasticity, for instance, you changed the elasticity to get some good results, but I think that when you did a full compile reset and everything, it switched back. So that may be affecting things as well.
Okay, I guess we should really note down what these things are. I'm going to do this, and I'm going to do...
Or put the values that you like as the defaults, so that when you put the effect back into the track, it's going to be in that place.
In terms of the envelope that is generated, it's like spot on, but I still don't see the old, I still don't see a random amount actually making a difference there. Do you?
So let's make it more random. Let's go to maybe 50 this time and blame the weirdness before to the elasticity.
Yeah, agreed. I want to move these a little further ahead. Blinks. And 50. I like the magic number at 2.5, and it doesn't clip, but that first bounce, we gotta fix that first bounce. Otherwise, pretty good progress. Shabloinks. All right, let's see if we see randomness occurring. It's still very linear. Why don't we not divide? Like, or divide by a small as heck number.
Sure,
Let's
yeah.
give that a go.
I suppose that's going to die off quickly. It's going to get louder too.
Mute the master.
It may get louder. Yeah, sure.
Hey, this one actually... Well, it didn't get longer, but it didn't get much shorter. Let's hear it. Why didn't we hear it? Oh, because we're not sending to the master on this one. Why did I do that? Because of a reason, I guess. All right, whatever. All right. Oh, I love that last part. I guess. Well, okay, so like. No, never mind. I thought this one may be thicker, but that's just the UI kind of messing up. You see how every once in a while one of them is a little bit thicker? But I don't think that's a sound situation. I think that's another thing altogether.
Yeah, so go more drastic. Make it the random divide very small.
Very small. Well, 1 doesn't make sense. 2?
Well, 1 kind of still makes sense. I mean, it's going to be, I think it's going to be crazy.
Oh,
but,
I see. 1 makes
2
sense
is gonna
because
be
it'll
as
just
crazy.
be the exact random thing that's generated. Right?
Yeah, the ranges is still going to be from -0.5 to 0.5. So it's still not going to go like, it's not going to go too crazy. Yeah, I don't think. I don't know.
That had a little lingering phase. Did you feel this? Now there we go. Now we have some randomness. Ladies and gentlemen, we have randomness.
We do have randomness.
Let's hear the randomness once again. And the timing randomness too. Did you feel that? So the timing on these two.
Yeah, timing is going to be related to the velocity. If we make the velocity higher, it's going to go further up, which is going to make it, it's going to take longer for it to come back down. But I just realized something. I am being silly. Because I am saying that things are between -1 and 1. That's not the case at all. We are talking about velocity. Velocity is not between -1 and 1. It's not a sample. It's a velocity. It's a different beast. It's a completely different thing.
Oh yeah, we're not adding to the like level of the signal. We're calculating physics stuff.
We are trying to mimic the effect of the ball bouncing more or less. So we are changing the velocity, and the velocity is not a number between -1 and 1.
It can be negative.
So,
in fact.
Oh yeah, the random part being negative is still makes sense because the velocity may get higher or lower. Depending on the random thing. But we don't have to be so careful about the range being between -1 and 1. The range could be between -10 and 10. Or we could bias it to maybe just be longer. So we could be maybe between -3 and 10. So it would be biased in one direction. It could be, we could do that as well.
So velocity can get smaller, can get bigger. I kind of don't want it to get bigger. Because then it loses its like linear downward thing. Like it's, it has this like, I do enjoy this. I do enjoy this part being more or less linear. I want the non-linearness more applied to the loudness. And even then I can take it or leave it. Do you know what I mean? Because I feel like the issue that happens here is you get a lot of like unintended like clusters of just weird rhythm versus like the other one, like the rhythms are going to be weird, they're going to be non-musical, but at least there is some rhyme and reason to them. Does that make sense to you?
Yeah, so in that case, if you are interested in only varying the sound, you can go to the next line. That is amplitude is equal to the velocity divided by sound decay. In the sound decay, you can multiply by a random value. And that amplitude is between -1 and 1. Hang in there. Is it?
It is.
No,
because our sound decay value is a magic
positive?
number too. So sound decay is magic. Yeah.
Sound decay is magic, but what we are saying is that the magic is now going to fluctuate.
Fluctuating magic sounds
ever so
good.
slightly. Yeah, so now we know the range of sound decay that we like, and we can tune the randomness accordingly. And you said that you always wanted it to be quieter but never louder. Is that right?
No, that part I'm okay with. I don't want the timing. I want the timing to remain linearly decreasing, but I'm okay with the velocity non-linearly increasing or decreasing. So I guess in that case...
Okay. If you excuse my pedantry, it is not going to be linear. It is going to be exponential.
Okay, sorry, yeah.
But move on. But yeah, you can remove the random from the previous line and do a random on this line.
Yeah. I guess the thing is exponential, but isn't the rate of decrease linear? Like decrease, also decrease, also decrease, also decrease, also decrease. So in that way, it's linear. It's not decrease.
The rate of change is linear. Yeah. So yeah, the thing is exponential. The first derivative of it is. That doesn't really make sense from a calculus perspective, does it? If something is exponential, can the first derivative be a linear thing? Yeah, I think it can, because we are not putting the variable on the exponent. Okay,
so I'll go rand on this one, and I guess we saw, and we can change these values in a second as our defaults. We liked elasticity at around 0.8, 0.9. We like the sound decay at 2.5-ish. And random divider for now, let's leave it as is. Or I guess the random divider, we also liked a somewhat smaller amount, but for now that thing is actually gone. But what I actually wanted to do was, so I guess if our magic number around 2.5 sounds good, why don't we make that change to like the range maybe be like 0.3 both ways or 0.25 both ways? What do you think about that?
Sure.
Okay. So it's sound decay, not times by, it's plus, right? Plus a random value.
Yes, and make sure to put parentheses around the whole thing.
Around this whole thing.
From sound decay up to the end of the line.
So I go rand minus 0.5. So that goes a negative -5 to positive +5. And we want to shrink this range, maybe divide it just by 2. So that is 2.525. So then I need another one of these joinxes, right?
Yes, and it ends there, and then you put the division sign. Yes.
Divide by, what did we say, 2? But I'll go again, random divider. And we'll set that to 2 by default, so we can play with that. But I guess we don't want to go too much because we already know 2 is like crazy or 0 is crazy. So I'm gonna hard code this. We can always change this. Deep, and then one more bracket for the whole thing, and that looks good.
That's not actually.
That may not be needed.
That is correct. Yeah, no, that is correct. Yes.
Okay, there we go. And did we get a okay from Daddy ReaFIR? We did. Now I'm just gonna, as a habit, I'm just gonna remove the whole damn thing because it seems to not give a rat's ass about nothing. Okay, the random values are there, all that stuff looks good, and let's hit it. Died a little quicker than I remembered, and that's because of this? Is it?
No, that's not going to affect the timing. No, only the elasticity affects the timing. The magic number does not, the random divider does not. If it died too quickly, then just increase the elasticity. Yeah.
There we go. So I guess like 91 hundredths is or 91 thousandths is a significant amount for elasticity. Cool. So we got to make elasticity fine.
It seems to be.
All right. Do we see randomness in velocity over here? Kinda, yeah. Look at this one. We got a random, right? This one's a little louder than this one.
Yeah, it looks louder. Yeah.
Fantastic. Let's scoop this range up. Yeah, to me that looks a tad louder. This looks a tad louder.
Yeah.
Awesome.
Yeah, and we can make it more drastic by making the random divider smaller. And Bo is saying something interesting in the chat. So the randomness decreases with every bounce. Well, not quite. In the way that we are doing it, because we are adding the random number, the randomness is the same on every bounce. Even if the sound is going to be quiet, the amount that it can vary is the same. Now, this is proportional to the velocity. So if the velocity is small, we are going to get a small variation because overall the value is small. But instead of adding a random number, we could multiply a random number. And the difference being, when you multiply a random number, the amount of randomness is proportional to the thing. So if you have a big number, it's going to vary a lot. And if you have a small number, it's going to vary less. Right now, it varies the same amount regardless of the number that you have. So 1,000 and 10, doesn't matter. It's going to vary the same amount.
Yeah, because it's an addition. So my other question, I guess, in this case is, so correct me if I'm wrong. Because this is in the slider value, this is generated one time.
Right. Yes.
Okay. Okay. Should we make this a thing and do a thing with it? Let's make this a thing and do a thing with it. But I'm gonna make the values different than the thing that we had. So default is, I guess we want to go like maybe 0, 1, something like that. To I don't want to go too high because we know the magic number around 1.5-ish is no bueno. So maybe 0.1 to 3 at a step. So.
Yeah, but you are thinking about it the wrong way. This is a divider. So the smaller the value, the more randomness we get.
Oh, so 0, 1 is too much.
I don't know. 0, 1 is going to be very random.
Oh, okay. That's
as much
random.
as I can tell you, but I don't know how it's going to sound.
What about 1.1?
But we can try that. We are playing around. Doesn't hurt.
Okay, so I'll put it here, but yeah, I understand what's going on now. Let's get rid of that. Let's mute that master for a sec. And I really hate that I have to do this, but I feel like I need to do this every time. Shibloinks, shifwamps.
I am doing it every time in development as well. I don't trust the reload thing.
Sorry, Bob.
Especially when it comes to user interface.
All right, should we get bold and do 0.3? My master's muted. Elasticity, I guess 8.91 is like how we like it. All right, let's go. Ping pong delay. Whoa, yeah, that's random as Czechoslovakia. All right. That clipped a little bit here and there, but I'm just gonna go a 1, a 2, a 3. Let's hear it. What up with that? Why did it get doubly duty? Is that human error? I want to record again. And to record again, I'm just going to bring this down in post so nobody's going to clip. Everybody chill the fuck out. Okay, that was my error. I don't know, for some reason it was a double duty.
Yeah.
Okay.
I heard that too.
The end sounds, woo, I love the end.
So I guess what you're saying is that you would like the randomness to be inversely proportional to the magnitude of the number. If the number is very small, it gets more random, and if the number is large, it gets less random.
Like I don't know if I wanted that, but like that's cool. Cause I guess another thing happens again. Just all I know about this is having recorded a ping pong ball drop a bunch of times. When you get to the end, something does happen to the amplitude where it kind of stabilizes until it drops, until it's like decaying altogether. And I think that's because, like, yeah, like a pitch emerges, right? When they get really close to each other. And you may just perceive that pitch for like 0.3 seconds or whatever, but it does occur. I mean, this is still not going to be in the loudness range in terms of frequency of the bouncy doos, but that sounds really realistic. Maybe not as much as to 0.8 maybe. Beep boop 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 boop. What am I doing? I really need to make some hotkeys for this setup because it's driving me up the wall. All right. I'm gonna do one more. Let's do one big one. I guess big one would be less noticeable. All right. Oh, you know what would be cool? Well, I'm not gonna do it. But it'd be cool if there was a wildcard that if you could make a wildcard from this value to print onto the files. But nah. We're getting nutty out there.
What do you mean? I don't get it.
You know, like you can have wildcards when you render files, like track number, track name, something like that. So it'd be nice if we could make this a wildcard so that when we record files, it says all the thingamajigs. Okay, I really like around this. So discounting this first thing, which is another weird thing. Shut up. So that was around 0.5. This was 0.9-ish. This is 3 and just very linear.
Exponential.
Sorry. Again, to me, the linearness means the decrease. like the way the sound changes is linear. Decrease, 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 decrease. And get shorter, get shorter, get shorter, get shorter. That's when I say linear, that's what I mean. But okay, I'll try to say exponential. Just straight. Just
But that's just it. It's not straight. It has a curve to it.
Yeah, but how the sound changes, because this is a delay, right? So the next delay with the next delay with the next delay with the next delay, how they change from each other is the same. Decrease, get shorter. Decrease, get shorter. Decrease, get shorter. But okay, I'll try to use the right terminology.
0.891.
Yeah. Okay. So. Well, okay. So I guess do you wanna try and fix the first bounce? That seems to be weird.
Yeah, that is something that we can play with.
Hi, John. What is audio taper? You gotta give us more.
Yeah, but hey,
Hi.
how's it going? So we can play around with that, but one thing that I think would be nice is to get to the user interface.
Okay. All right.
And yeah, I wanted to have something on that area done today.
Okay.
I thought it could be fun. Especially, do you have that image that you had on the thumbnail for this stream?
Yes, sirree. Yes. Now, whether I can find it real quick is another thing, but I can definitely show you the thumbnail real quick. Let's.
Oh yeah, we can do that. I just want to see that figure because I think that is what we need for our interface.
Yes, Weepsity. Whoa. Come on. All right. Doing.
Yep. And you can see. Can you see a curve? If you just look at the peaks, can you see a curve to them? And it looks like an exponential curve, right? And it is, in fact, an exponential curve. And the coolest thing about this figure is that it's even modeling something that we are not. It's modeling the time it takes for the bounce to happen. It's not instantaneous. There is a transfer of energy from the ball to the desk and then back. Second law of
Aren't we doing that? We are doing
motion. Nope. So you look at, for instance, the first bounce, it happens at 1. Time equals to 1 in that figure, but you can see that the line going down and the line going up are not touching. There is a little bit of space there, not on the peak, but right there.
It's a hold value.
Yeah, so it's just for a little moment modeling the fact that the ball is interacting with the desk, and then all of that we are just ignoring. In our notion, when the bounce happens, it immediately the ball immediately goes up again, and that's not. It's just what we are doing, right? We are not modeling that little bit of time it takes for the ball to actually bounce back. But I don't think that matters in terms of sound. I don't think it matters in terms of visuals either. In fact, I propose that we just have the user interface show this figure, because when you play with the sliders, you're going to see the figure change. You're going to see some of the peaks get louder. All of those things that we are measuring painstakingly by running the effect over and over, we'll be able to see. And I think that's super cool. So now what I propose is that we draw this figure. And then there is in my library already, the library that we are using, there is a function that allows you to draw a waveform. So my vision for the user interface, I actually have 2 options, and I want to run these options by you. I don't think we'll be able to fully flesh this out, but the vision is, number 1, like I explained before, we draw that curve, that graph that you were showing us, and then we let the waveform travel that path.
Okay, gotcha.
And then we plot the waveform on that path. And that's option number 1. And then you could imagine that when the waveform is hitting the desk, we hear it. Option number 2 is we have that graph and we plot the waveform below. So you would just see the line touching the waveform as a tap.
I see.
A literal tap in this case. It's just literally tapping the wire at that point, and we can listen to that. So which version do you think works nicer? Which version do you prefer?
Questions about them. First thing is, when we say like see the waveform travel, since it is a continuous signal, are we detecting a transient and then taking that as the ball and that moves? Because imagine if I have a pad, what part of the pad is traveling through which part of the thing? You know what I mean? Like we're assuming that there's a window of wave and that's our wave and that begins to travel, right? Is that how you're imagining it?
No, I was not imagining we would track the transients, though it is in the to-do list. We could just trigger the delay when we have a transient. That could be fun. But I was thinking it as just a waveform, the same way you see a waveform when you are looking at ReaFIR executing, when you're playing the timeline, except that the waveform would be traveling that path. And as new sound comes in, the new sound starts on the top left and goes and travels the way.
Cool.
And then we are going to hear the dry sound is just the sound at time 0, regardless.
Gotcha.
So that's the dry. And we need to have a dry wet kind of slider. But then the wet is just the bounces as they happen.
So my other question is, are you imagining it a ball hitting the floor and going up on the same like on the same location on x-axis, or is it going also right to left to show time? Do you know what I mean?
Yeah, so I was not thinking about drawing the ball. If we execute the idea number 1 that I had, then the sound itself represents the ball, because if you see some characteristic of the sound, like if you see a transient, you will see the transient moving like the ball would over time. So it is as if not you're letting go of the ball, it's as if you're throwing the ball horizontally.
Okay, gotcha.
Or if you prefer to look at it in the way that the graph is showing, it is as if you're letting go of the ball, but then you're looking at the position over time. That's what the graph is right now.
No, I like option A. Not seeing the wave behind. Okay. I like I think that just would look kind of more interesting too.
And the mathematics behind that is actually more interesting, because we will have to find a path.
Yeah.
We need to draw this figure, and I think that's about as much as we will be able to do today. But we need to draw the waveform, and that's relatively straightforward. But to draw the waveform following the path, there is some interesting mathematics involved. It's nothing crazy.
Yeah.
But it is sort of cool, because we need to distort the waveform to make it follow a path.
Oh, let's do that. Oh, thanks, John, for dropping by. I got what you were saying. Yeah. I thought audio, when you said audio taper, I thought you mean like a plugin that already does this, and I got scared. But whatever. Even if a plugin did this, whatever. All right. So let's draw this GFX.
Oh, but that's actually interesting. In electrical components, you need to use an audio taper potentiometer for volume adjustments.
Yeah.
Okay. All right. So let's start a GFX block.
All right. It has to go before the sample block, right?
Doesn't matter. Can go anywhere.
All right. In that case,
typically,
can I go after the sample block?
Typically, people use init, slider, serialize, but that's serialize can pretty much go anywhere, and then sample and GFX.
Okay. Let's do what people typically do. Yeah.
Yeah. The reasoning being, the init is, I guess, pretty obvious. It happens first when the effect loads, so the code is in the beginning, and typically in the init block, you're going to initialize variables, so it makes sense to have them above. Then slider, the next block that runs, and if you move a slider, it's going to run again, okay? And then serialize is typically related to the sliders. Typically, you have something in the sliders, and then you need to store it in a more sophisticated way for whatever reason. Like, one thing that comes up often is if you have a sort of a sampler, then in the serialized block, you would remember the sample.
Yeah.
That's where you would store the file with the sound of the sample. So that's why it comes after the slider. And then sample, obvious reasons. And if you have a block, it usually goes before the sample block. Yeah, so block, sample block, and then GFX usually comes last, because usually that's the thing that is... You think about it less.
Yeah,
usually.
And it's going to get like long as well, and then it will create a huge division, like kind of between the start of your code where you're introducing variables and then going down to sample to see what's going on. So cool.
Yeah.
All right.
Well, yeah. Well, in fact, usually for effects that do anything interesting visually, the GFX block is usually way bigger and way more complicated than the sample block. And I guess for a good reason, right? Because in the sample block, if you have too much code or if the code gets too crazy, you're going to drop samples.
Yeah.
It's going to be too slow. You want to keep it short and sweet as much as possible.
And I mean, I doubt that we can make the GFX for this thing be less than like 10 lines long, so...
Well, to be fair, the sample block is kind of cheating, isn't it? Because it is using variables that were computed in the slider block. The bulk of the work was done in what we call the data storage loops on the slider block. And then on the sample block, we're just using the variables. And that kind of makes sense. Usually, if you can, pre-compute stuff and use it in the sample block. Don't compute stuff in the sample block. For instance, if you're doing a filter, compute the filter coefficients in the slider block or somewhere else. And then in the sample block, just use the coefficients. Right. So in the GFX block, we need to plot that line. That is kind of awkward because all the information about the line, like how wide the bounces need to be and so forth, all those things, we're sort of computing in the slider block. So how about we maybe add stuff to the slider block to compute this curve, and then in the GFX block, we just render that to the screen.
Sounds good.
Does that make sense to you?
I'm going to make a new section. We can rename that data storage loops thing too, because I think we changed the code. But I'm going to call this GFX components for now.
Sure. And specifically, what I think we need to compute there, I mean, there are different ways of going about this, but I think that the easiest is to just compute the position of the ball at certain points in time. So right now, we are just computing in the data storage loops right above. We are just computing things like what is the velocity when it hits the desk, what is the how loud is the sound supposed to be and whatnot. But what we could do is use the equations of motion and go step by step in the equations of motion. So we are going to say that we will compute every 0.01 seconds, and then we are going to use increments of 0.01 and compute the ball position in all those points.
Cool.
So what we are going to effectively be doing is computing each point in the graph. We are not computing the curve, we're just computing each of the dots.
Cool. I guess 0.01 seconds is too much because that would mean a frame rate of 100 for our GFX. But really, if we hit 30, we're okay, right? Even if we hit 25, we're okay.
It's not a frame rate kind of thing because we are not thinking about this, how it progresses over time. We would be thinking about that if we had a different visualization, which was like the ball bouncing. If we wanted to have that sort of visualization, then we would think of frame rate. But what we are doing is drawing the ball over time, the position of the ball over time. So we are going to do this computation, and we are going to find all the dots, and then we are going to plot all the dots on the page.
Cool. I have another question for you. Just to make sure that I understand your GFX vision more or less. But say the GFX is done. You load the plugin in. You haven't played anything yet. Are we seeing something bounce based on the parameters that we have set, or we will only see something once sound begins to come in?
Well, I think that we could draw a little line. No, we actually don't need that. I was going to say that we could draw a little line on the path and then draw the waveform as it comes in. But if there is no sound going through, the representation of that is a straight line. Right? That's how you see silence in ReaFIR. You see a straight line. So we would just draw that straight line, and it would draw pretty much the figure you showed us before.
I guess it would be cool, like, if you're stopped, but you're just trying to, like, adjust the parameters. So, like, oh, I'm okay with the amount of bounce. I want the whole thing to be faster. It'd be nice to get a preview of some sorts, but if it's too crazy, let's not do that yet.
You are going to. No, you are going to get this. In the slider block, if you change one of the sliders, it's going to rerun this code that we are about to write, which will recompute the line or the dots that I'm talking about. And then you will play with the sliders and you see the form changing in real time.
Cool. All right, I'm on board. 100%. Let's do it.
All right. So I think that the first ingredient we need is the equations of motion again, because we are going to use the equations of motion in a slightly different way. Previously, we resolved the equation of motion for time and then for velocity. Don't comment
No,
that out.
I
That's you
was
host, okay?
just writing something. Don't worry about it. All right.
Okay. Yeah, so previously we computed things like the bounce time in seconds, so we resolved for time. But this time we are not interested in when the ball is going to hit the desk. No, we are interested in like simulating the ball moving. And we want to compute the points in time. So we need the equations of motion again. Can you open up the Wikipedia article?
Yeah. I bookmarked it. But I'm
just
gonna,
Google for equations of motion.
Come on, fella. All right.
And then look for section 2.2.1, which is constant translational acceleration in a straight line. And there you have it. Again, it comes in 5 flavors. We are using flavor number 2 for this one because R is the position. That's what we are interested in. Where is the ball? And then V0, we know that's the initial velocity of the ball. It's 0. We are letting the ball go. We are not throwing it. T is the thing that we are going to be stepping. Yeah. So we are going to look at T equals 0. That's when you let the ball go. T equals 0.1. That's 0.1 seconds later. 0.2, 0.3, 0.4. And we are going to compute R for all these T's. And we are going to store the results. And then we are going to plot it. And then plus a half of A, acceleration. We know that's the acceleration of Earth, of gravity's, of Earth's gravity, and we already have that. And then T again. So yeah, we have everything we need. We just need to have this equation number 2 and iterate over it. In fact, yeah, let's start implementing this.
So should we do it like the way we did it last time with the old, sorry, let me get my apples in order. Beeps, boops. Like write the whole thing, then replace the values, or can we use the same simplified equation from before?
No, we cannot use the equation that we used before because we were massaging the numbers in a different way. But let's start from scratch. So let's write the Wikipedia equation number 2, but let's give the variables a better name. I mean, if you want to go with R, then okay, but I kind of hate this short name, so I would say something like position.
We already have position initial. Can we use the same one, or do we want to use another thing?
I am not sure how position initial is used. I think it's the slider, isn't it?
Position initial is, I think, the distance. Yeah, yeah.
Yeah, it's this slider. Okay, we are going to use that. That's R0. R0 is position initial. But I think that this is just in position. In the formula, it's just R. R is current position.
R0
or position,
is position
for
initial.
Sure.
Cool.
And R is maybe just position. Yeah. And then plus, and then V0 we know to be 0. So that one we don't need. And then half of acceleration. We have a variable for this, don't we?
Yeah, I think for acceleration, if I go to the slider block.
Yes, we can see that we have a variable for that.
You saw it? Oh, you saw it here. Yeah, so I'll just use acceleration.
Yeah, the first line of code in the slider block.
All right. Times. And then T is our peak time. No, not peak time. It's bounce time seconds.
So now, no, it's not. This t is the variable that we are going to be changing over time as we compute the position of the ball. Remember that in the graph you showed us before, the x-axis was time, and t is time. So that's the thing that is going to vary. We are going to go from t equals 0, t equals 0.1, and t equals 0.2, and so forth. So for now, just multiply by time, and we need to make this variable up.
Okay.
And it's the square of time, so you need to say
well, we can't call it time, right? We gotta say, why don't I just call it square of time? And then, cause I don't want to call it time, cause that's a thing. So why don't we define square of time as square of, I guess, another variable called time?
Yeah, see, usually, I mean, there is no convention for this, okay? So you can go with t if you like, and that has some resemblance to the Wikipedia equation, which is sort of nice. But the way I would do it is I would use like underscore time or something, or time underscore.
Okay,
I know it's silly, but it's something that you may find in other places where there is a reserved word in the language and you want to use that reserved word for whatever reason, then you put an underscore before or after. Cool. Now we need to make this variable up, this time variable. So how about we have a loop for this?
Cool. I guess I'll call it a time loop. Time loop. All right, let's do it.
Yeah, so you can say underscore time equals to. Now, we could hard code a number here, but we could also make that kind of a slider to help us tune this value in a way that makes sense. Yeah, let's make a slider that we call the time step.
Cool.
And that's the increases in time that we are going to apply to the value.
I'm just going to put some random numbers here. Oh, this is going to come plain? No, it's not going to come plain. Okay, time step. So what kind of values do we need from this? Well, 0 can't we?
Yeah, so this is not underscore time, okay? This slider is not underscore time. This is the rate of change of underscore time. Okay. You can call it time step if you want. But this is how much are we going to, in other words, we are going to compute the dots that make up the graph. Yeah. How far apart in time are these dots? What is the resolution of the graph? How zoomed in are we into this graph? Yeah. And I don't know exactly which number to pick here. So maybe go with 0.1, maybe.
Cool. Until 10?
That is definitely too much. I think we are talking about like 0.001 to 0.1 or 0.2, something like that.
And let's do that. And the default, I'll just...
Yeah, and make the default value something like, I don't know, I don't know what to say, 0.001.
Okay.
Yeah, there you go. That's nice.
Cool.
Yeah, whatever you want to do it. So now move down, and in this thing that we are doing, we are looping from 0. Yeah. That's when the ball is being dropped. So we are moving from 0 onwards. Mm-hmm. So let's start with minus time step. Mm-hmm.
Like this?
So, no. Underscore time equals minus time step.
Minus time step. Sorry, let me get rid of this bit. All right.
And then semicolon and loop. And then we need to say how many times do we want to loop for. Mm. And I'm thinking of this as like little dots on the screen. So let's again, we have to be conservative and we need to overestimate. So let's say that you have a 5K display and you have our effect full screen.
Okay.
How many pixels do you have on the horizontal axis?
I don't know the resolution of 5K off the top of my head.
Yeah, let's find out. 5K display. A 5K display is like a Mac, an iMac,
It's
right?
5120.
iMacs with 5K. There you go. So yeah, that's going to be our number.
So loop 51020 times.
And then on each time, we want to say underscore time plus equals time step.
Wait, do I write this again?
Plus equals.
Oh, yeah. Oh, gotcha. I'm a bit behind on GFX, I'm assuming, for a while until like I see something, then I'll get it. So you're going to be ahead of me. Well, you're always ahead of me, but you're just going to have to tell me what to write then. All right. Okay.
That's perfectly all right. Yeah. So another thing that I usually do is I usually go to the next line and I put close paren semicolon. So this way I won't forget to do it later.
And then
I move up and let's start writing the body of this loop. Well, we already started the body of this loop. It is the lines below. So you can move these lines in the GFX components part where we compute the square of times and then the position. All of that needs to go into the loop.
Shablamps. And I'll make this like this, and I'll make this like this.
Sure. Yeah. And now we need to store this position somewhere because the position is going to be used below in the GFX block. So how about we go to the init block and we define an array.
I want to see, let me try. I'll probably won't be able to do it, but I want to see if I can do this on my own. Okay.
Go ahead.
Okay, so I'm going to call this, and maybe, I don't know, maybe you won't agree with my namings, but I'm going to go like underscore time struct and then define a struct here. Yes.
Yeah, go ahead. While you're writing the thing, I will answer to Will Padgett.
Hi, Will.
Holy crap, what have I walked into? I'm scared but curious. Welcome, Will. Great to have you here. And yeah, we are doing a ping pong delay that simulates a ping pong ball falling on a desk and then bouncing back. And that determines the taps on the delay. And that's what we are coding together here. Enjoy your stay.
Oh, okay. If I got this one wrong, then you'll tell me. Why do you go up? Don't go up, go down. Let me just go here so that the suggestions go down because I'm trying to copy from above there. Am I in the ballpark so far? Field.
I'm looking at where we are going. I want to see where you're getting at.
All right. I guess I don't know if other than step we have like additional things we need to do, but then I'm gonna go underscore time equals array new, and then for this do 5120, and then I go, and then we need to index it, so I go, I'm kind of copying your code, so I'm not doing anything too crazy. But we need to index this thing, so we start at -1 and we loop the thingamajig at underscore time in the position of underscore fuck.
Okay, let me tell you something. Yeah. Let me tell you something about the tab. The tab needs to be a data structure because a tab represents two pieces of information. First, the time. the time when the tap is going to happen. And second, the level, the amplitude. How loud is that tap? And that's something that translates to normal EQ, normal delays. If you go to redelay, there will be a timing thing and dry, wet, or loudness or something. So that's why a tap has to be a data structure, because it stores two pieces of information, but the time
does not.
This array that we are talking about here is not even about time, it's about position. So this is just an array of positions over time. The time is a variable that we already have. In fact, underscore time is something that we already have in the loop. If you look at the loop below, you will see that we have an underscore time. It's completely defined, and we are fine using it. So we don't need to store the times. We need to store the positions. So the way I think about it is we don't just need position. That's one thing, one number. It's only the position in the y-axis. The x-axis is the time. We already have that. So we just need to store positions. So I would say positions, plural, equals array new 5120, and that's the end of that. That's all we need in the init block.
Cool. In fact, I'm going to do it like this. U, Y, whoop. All right.
Yep. And then you don't need that next line that you were writing.
Cool.
Yeah. So now we have this positions array, and we can store the positions as we compute them. We have already computed the positions below. In the loop, we have a line that reads position equals something. So we're calculating the position. But right now, we are calculating the position and we are forgetting it.
Yeah.
Right? That's what we're doing. We're just forgetting the position. So now we are going to store the position in the positions array.
Cool. So we go positions index, I guess, right?
Yeah, you need to go back to the loop below.
Yeah.
And you need a bunch of semicolons in those lines. You can take this opportunity to actually put the semicolons there. And then on the next line, we need to say positions. And then at some index, because positions is an array, so we need to say at which position it is, but we don't know exactly which position to use right now. So just close bracket, and we'll get back to this in a moment, equals position.
Gotcha.
And now is the time where we get back to the index. So how do we know this index? Well, we want to start at index 0, and we want to go up to index 5119, which is one less than 5120. So don't change anything about this part of the code in the init block. You can leave that. Don't do it. But the line that you are about to write is good. It's just in the wrong place because it needs to be closer to the loop below. We are now looping over two things. We are changing the time, underscore time as it is. We are changing underscore time, and we are changing the positions index. So go below where you have underscore time equals minus time step, and add another line there.
Below or on top?
That reads like... it needs to be outside the loop.
All right.
Yes, so there you can say something like positions.index, if you will. It starts with -1.
And then you go loop.
And no, you don't need to loop. The loop is the same.
Oh, okay, gotcha.
It's just that we are going to be tracking two variables in the same loop. So put a semicolon there so we don't forget it. And then in the loop, maybe as the first line in the loop, you can say something like positions.index plus equals 1. Yeah. And then now we have positions index. That is a variable that is going to start with 0, and then it's going to go up to 5119.
Cool.
Great. So now when you say positions at, you will have to do something that I may change in a future version of the library. It's still a work in progress. But right now you do have to say, you see how like above when you have a line that starts with taps, you have taps at underscore array struct data.
Yeah, right here.
Yeah, so we need something like that. You need to say array struct data and then positions index.
Okay. So how come that's just a white color? What up with that?
You were expecting it to highlight differently?
I was expecting it to be like yellow since it's predefined, but I guess because it's just a name, right?
Yeah, yellow is our functions. These are not
Okay.
functions. These are just, yeah. Square brackets are not for calling functions. They're for accessing memory. A different flavor of operation.
Yeah. And then positions index goes there as well, right?
Yes, exactly. You have the right line. Just put a semicolon at the end, and this is it.
Cool.
We are computing the bounce.
Cool.
There is a problem with this, but we are going to deal with that in a moment.
Okay.
First, I want to actually see that.
Okay.
But there will be a problem. So just so you know, there will be a problem, guys. But let's move on to the GFX block and try to draw this.
There we go. Here we are.
We now have a positions array. Yeah, and in this, we are going to do something that is similar to the loop we had above. So maybe you want to copy something like positions index equals -1, or maybe just copy the whole loop you have above from positions index. Yeah, copy all that, and we can remove the parts we are not going to use. Specifically, we are not going to use the square of time onwards.
Square of time onwards by.
Yeah. Now, what we want is maybe to... How about we draw a little rectangle? So there is an issue with drawing lines in JSFX. You cannot draw a thick line. You can only draw lines of 1 pixel. And that doesn't really translate well on the stream, and it doesn't look nice. So how about, instead of doing that, we plot every pixel as a little square.
Sounds fun.
Okay, so go to the line right after positions index. And no, positions index in the loop.
Okay.
And then to draw a rectangle, I sure know how to do this.
Set rect.
I am not going... If you know how to do it, I am definitely not looking up the documentation right now. I'm not. Okay, here it is. I was looking at the documentation, you all, and now I know how to draw a rectangle. You say GFX _rect.
Oh, okay. Yeah.
And then you need to give the X and Y coordinates. Now let's think about it. The X coordinate is our time. But let's not use the underscore time variable because that is in seconds, right? The underscore time variable is in seconds. We need to give this coordinate in pixels. So we have a very convenient variable that is already ranging from 0 up to 5119.
Yes.
And that's our x-axis.
Yeah.
Do you know which variable I'm talking about?
I'll tell you in a second. Positions. Yes.
That is an array of positions, but I'm talking, that's the y-axis. I'm talking about the x-axis. Just look at the setup of the loop we have in the GFX block.
Okay.
We have 2 variables. And I just told you that underscore time is a bad option because it's in seconds. We want it in pixels. We have another variable in there. What is it? That's, again, about time. The increments in time in seconds.
So it's positions index.
There you go. Yeah.
I only got it wrong twice in a 3-option multiple choice.
Yeah, but there is a wrinkle here. Positions index is going from 0 to 5119. And that's good if you have a big 5K monitor, but you don't. I don't. So how about you divide this number? Or actually, let me think about it. Yeah, you divide this number by its range. So it's going to go from 0 to 5119. So let's put 5119 there. And now this number is going from 0 to 1.
Yeah.
Am I right? So you can multiply by the width of your window, and that's going to give you a pixel on your window, not on a 5K monitor, on your window.
Is it better to calculate this as a thing outside this before we put it all into the GFX rect?
That's up to you. If you want to extract a variable for that and call it X or something, that's fine.
Okay, I kind of want to do that, yeah. So X, let's call it...
It needs to be in the loop.
It needs to be in the loop. Oh, okay. So, okay, I'll go below. X is no good also. I guess I will say... I'll say screen X. I don't know, whatever. We may revisit this. Is positions.index divided by 5119. And then that whole thingamajig is divided by... multiplied by or divided by?
Multiplied by. Yeah. It's a number between 0 and 1, and we want it to be a number between 0 and your GFX width.
Cool. So like this. And shabloops.
Yeah.
And so I'll just call
and now
screen X. Screen X, and then for Y, our Y is you already said it, and I already lost it. It's the position. No, I don't know. Tell me.
The Y is complicated. The Y is we want to translate a value in the positions array. We have a positions array that is storing all the positions in meters.
Yeah.
Right? Those are positions in meters. Oh, that just reminds me. Acceleration in that formula should be negative because acceleration is moving
downwards.
Down.
Okay.
So, yeah, go back to the loop where we are computing the position. And that's the line that reads position equals position.initial. And then you have half times acceleration. That should be minus acceleration.
Cool.
There you go. And then, so below, we do have this position that we can get a hold of. So yeah, maybe let's start with that. Let's have a line that reads position equals, so a line before the GFX rect thing. Position equals...
We already used position somewhere, didn't we? Oh, we used it up here. Is that cool? That's good.
Yeah, but that was in the in different block.
Cool.
Yeah, if we used the same variable name in the sample block, we would be in trouble because the two blocks run at the same time. But the sample block is not going to run this at the same time as the GFX block that I know of, in any case. So that is equal to positions at underscore array struct data at positions index.
Why did you not suggest me this time? All right, whatever. Okay.
So that's our position, but position is a variable measured in meters. Now we need to map these meters into pixels on the screen.
So we got to use this thingamajig and then multiply by GFXY.
Well, that is not really doing us any favors. We needed the other value to know how many dots to compute. And now you have already computed the dots. It's just a matter of putting them in the right place. And to put them in the right place, we did not use this number. We used GFXW, right? So we are going to use GFXH for height this time. So let's think about this number. It's a position in meters. What is the range? Well, it starts with 0. That's our desk. It starts with 0. But then it goes up to what number?
I guess that's... We said 2 meters is the max, I guess.
There you go. So it goes from 0 to 2 meters. Great. So our screen Y... Let's start writing that line. Screen Y is... I'm going to need the position variable, so that needs to be after position. Or if you want, you can move the position up before screen X and Y.
Whatever, we'll clean it up after. Okay, screen Y equals.
Yeah, so now we have this position number. Position is a number between 0 and 2, right?
Mm-hmm.
So divide by 2. And now this is a number between 0 and 1.
Yes.
And multiply by your GFX age, and it's going to be a number between 0 and your height. But there is a final problem, which is it's going to be upside down, isn't it?
I guess we can see.
Yeah. No, it's going to be upside down. We can tell because the way that the window coordinates work in GFX is the top left is 0. But in our system, we are thinking about the desk as 0 and positive values going up. So it's going to be upside down. So to fix this, all we got to do is just take GFX age minus whatever we have there.
Okay. Minus this? Minus itself?
No. GFX age minus the formula you currently have on the screen. So you, in the beginning of the line, not in the beginning of the line, in the beginning of the formula, sorry. In the beginning of the formula, so that's the line that reads screen Y equals, and then put your caret there. Right after the equal sign.
Right after the, yeah.
Put your cursor right after the equal sign, and then you can write GFX age minus.
Oh, gotcha. GFX age minus.
And that's going to flip everything upside down.
This entire situation. And we don't need this.
Yeah.
And
strictly speaking, you don't need the parentheses because multiplication has a higher precedence, but do whatever you feel comfortable. In fact, you don't need any of the parentheses on this line. They're all the operations are going to happen in the right order.
Cool.
Yep. Right. Okay. So now you have your screen Y. Great. So coming back to the line that reads GFX rect, put screen Y there, and then we still need the width and the height, and that is just going to be the size of your rectangle or the size of your square. This is going to determine the thickness of the line. So maybe put some value like 3 for a line that is 3 pixels thick.
Okay.
And you also need the height, so it's 3, 3.
And oops.
And a semicolon at the end, and let's look at this.
All right, moment of truth, everybody. Full recompile reset. Close this. Drop this. Put it in. Moment of truth. Are you ready? I said...
Oh, no. There is one more thing. I know one more thing that is going to go wrong. If I remember correctly, by default, ReaFIR is going to draw in black on a black screen. So we need to say what color we want. So go back to the script, and I already know that with this, we are only going to get a black
screen. We got something.
Oh, no, I'm wrong. We got something. By default, ReaFIR draws in white. Who knew? So this is a first bounce.
Wowzers.
Cool,
That's awesome. So here's my question. We took the whole range thinking that the maximum... Oh, so I guess... There we go. Oh my God. Forget about it. Awesome. All right. That's just great stuff. And the aliasing is we addressed in the ReEQ episode if people are wondering. And okay, if we said, all right, we're cool with a 1 pixel line, that aliasing would go away? Right?
No, it's not that simple. The problem is there is no way for you to draw a curve like this. So that's another limitation. First limitation, lines are only 1 pixel thick. Second limitation, you cannot draw curves. I think there is a way for you to draw a section of a circle. I'm looking it up. And arc. Yes, you can draw arcs, which are sections of circles. So if you wanted to get really fancy, you could try to come up with an ellipse that would do this. No, that's not possible. Because, it's not possible because this is not a circle.
Yeah, exactly.
And an arc needs to be an arc of a circle in GFX.
Yeah, lame.
And so two limitations that we have. Lines are only 1 pixel thick, and you cannot draw arbitrary curves. You can draw sections of circles, arcs, but you cannot draw arbitrary curves.
Cool.
So the only way you can do that, if you want to show something that is curvy, is you have to break it apart in either line segments or, as we are doing it, in a bunch of little squares. We need to take each pixel and just draw each pixel of the curve with our bare hands. That's what we are doing now. We are drawing each pixel of the curve with our bare hands. And then if you zoom in, you will see the aliasing. And this is not sound aliasing. This is visual aliasing. And there is no best way of getting rid of that aliasing. But what I'm finding with my experiments is that if you have fewer line segments, then it is going to be bumpy, right? Because if you have fewer line segments to approximate a curve, you are going to start seeing the line segments. But at least ReaFIR knows how to anti-alias a line segment. So if you calibrate this very carefully, and the calibration depends on curve, but if you calibrate this very carefully, you can leverage the fact that ReaFIR is going to anti-alias the line segment, and if you have just enough line segments, it will not look too jumpy, and it will be anti-aliased. But in general, I think it's fine to live with the aliasing. That's what ReEQ does, for instance.
Yeah. No, we can live.
And I think it looks okay.
Great, yeah.
Yeah, if you want to get fancier, then I think that you are beyond the capabilities of GFX as a drawing engine. And I mean, in theory, you could implement your own anti-aliasing routine, and then you could compute which squares need to be gray to anti-alias this white on black situation. But I don't want to get into that business. I'm fine with the aliasing. Or go to something like C++, write your effect in Juice, draw your user interface in SVG, be happy.
Yeah.
I mean, go do what the FabFilter guys are doing. They look great, but I'm not getting there.
No, yeah, I like this.
It does give it I don't want to justify the limitations, but it does give you a kind of lo-fi,
it's like Snake,
old video game, Commodore 64 kind of feel, which is not entirely bad.
Yeah, I totally agree.
It goes along with the rest of the user interface in ReaFIR, which is kind of crappy. All right, so I said that there was an issue. What is the issue? Can you tell me the issue?
Well, I guess we are not gonna, if I play the sound now, we're not gonna see any bouncing happening, right?
No, there is that. The sound is not going to be affected. We didn't change anything about the sound processing. But we are not going to see any waveform, and that's fine. But there's a big issue, Arya. It's not bouncing back. It's going down, and it's never coming back.
Yeah, that's what I meant. Like, yeah, we're not... We should see chap, 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 but we're just seeing that.
Yeah. And why is that? Can you tell? Given the code we wrote?
Let me tell you real quick. We're going positions in, so our X is positions index, right? And we're giving it like all the space it needs and all of that. But we haven't really like indexed the position because we calculated, where is it? We have time. We calculated time and amplitude. We never calculated the positions because we didn't care when we were generating the sound. Am I right?
Yeah, but look at the GFX components block.
Oh, okay.
There is an issue in that loop, not in this portion. Go above, and you have a comment that reads GFX components and time loop. Yeah, in there. There is an issue there.
We got the position, we got the thingamajig, and we got the position index equals position. No, I don't know. Why am I lying?
We have a problem there. The problem is that when the ball reaches position 0, it should bounce back. But we are not bouncing the ball back. We are letting the ball go through the desk into the bottomless infinity of negative numbers.
Cool.
Position should always be 0 or positive. But right now, position is negative. And of course, GFX, when we are asking GFX to plot that, it's going below the bottom of the screen, so we don't see it. So right now we have just one parabola that goes down and goes deep into infinity. We need to make the ball bounce.
Ooh, sounds like trigonometry somehow, but no.
It's not that complicated. So now we need to go back into the equations of motion.
Yeah.
And
or do you want me to go to the wiki?
Yeah, go back to the wiki where we see equation flavor number 2. And we need to have some computation here. We need to compute something. We need to look at position. So you have a line that computes position and we store position. Great. After we have done this, we need to look at position and we need to see, okay, did we go over? Are we negative now? Because if so, then we are in the wrong location. We don't want to be below the desk. Let's change things around. So let's do the bounce. What is the bounce? Well, the bounce is we need to change some of our variables around. We have an equation of motion that reads R, which is our position, that stays the same. R0 is going to change because on the first bounce, R0 is no longer where we left the ball. R0 is 0. It's the desk. That's the initial position. And then V0 used to be 0 because we let the ball go. We didn't throw it. So V0 used to be 0, but now it's not 0 anymore. V is the... well, we need to compute it actually. Or we could take a peek at the velocity that we computed above. But we need to compute V0. Then T we already have. T is not going to change. Plus half of acceleration is not going to change and time is not going to change. So yeah, we just need to reconsider what is our R0 and what is our V0. And then we just let the loop go around and it's going to compute a new position for us until it reaches 0 again. At that point, we'll need to bounce back.
Yeah.
Does it make sense to you?
Theoretically, yes. Yeah, like, so the values go like, they're going below. Once they hit 0, we want them to bounce back up. But again, they're going to hit 0, go below. So we need to, again, tell them to come back up, like wrap back up to, yeah. So let's start by massaging the code that we currently have. Because when we were writing the code, we said things like, okay, the initial velocity V0 is 0, so let's not even put the term in the formula. But now let's be explicit and have variables for this. So before the loop starts, before underscore time, let's have a variable for initial position. And it can be position
that
initial,
variable will have to change
from that we had before.
Yeah, but we need a different name for this because we are going to change this initial position to be the desk at some point. So give it a new variable name and you can come up with whatever name you feel comfortable.
Position desk. It's a terrible name, but
well, it's not exactly true because that's the initial position that you are letting go the ball on the first iteration.
Yeah, I just don't know what to call it.
But whatever, if you like the name, you can keep it.
We'll change the names. Like we'll do after we're done. Some of these names are probably subject to change, you know?
Sure. So initially, it's position.initial. So you can start the variable position desk with position initial. And semicolon, and then on the next line, we need the initial velocity. But let me think about this. Yeah, velocity is just going to change over time. So you may want to just call this velocity if you feel like it.
We already have velocity too.
Yeah, and that's fine because it's in a different block. But if you want to give it a different name to be explicit, it's fine. You can do like velocity desk or whatever.
All right, we'll call everything for now desk.
So we know that it's initially what is it?
Zero
What is
at
the
the
initial
beginning.
value of this variable?
Yeah.
It is. It's 0. You are right. So those are the two variables that we have omitted before. So that's fine. So let's go now to the line that reads position equals. And we are going to change some things over there. Position initial is now position desk.
And then we omitted this bit of the formula. Now we got to add it back, right?
Yes.
And let me just schmutz this a little bit over here. Boop, 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 boop. I lost my thing. Okay, position desk plus, so plus I'm going to go velocity desk times, fucking underscore time, right?
Yeah.
But this time I need the thingamajig. I need one of these. No. You don't. Yeah.
You can just say plus. That's fine.
Yeah.
Great.
Cool.
So far we didn't really change much. We just added some variables.
0, yeah.
But we can now go to the next line right after you have computed position. And you can change some things around. You can do, first we have to check if we bounced. So you can do something like position less than 0. Or even less than or equal to 0.
I always get
let's do less than or equal to 0. It's in the order we say it, less than or equal to. So less than equal.
Like this? Cool.
Yes. So if it's the less than or equal to 0,
Joops.
question mark, open parens, close parens, semicolon. Good habit to get into.
Cool.
And then in this parens, what we want is to update two things. We need to update. What two things, Arya?
We need to update the position desk and velocity desk.
Exactly.
Yeah.
So write two lines that read position desk equals and velocity desk equals.
Why? Why do you not give me the exact thing that I need there? What the fuck? I really want this auto suggest to like work for me, but it finds almost like the most intelligent way of not working for you. It's crazy. Like where is it? The one that we want, that's not there. Cause, what are you, high? All right, let's. Whoopsie daisy.
So now position desk. What should position desk be?
Position desk should, when it's not 0, should go back up. I don't know. When it's negative, it should just wrap
so
back.
that's the position where we are starting. So that's the position where the position desk is kind of a misnomer because that's the position where we are starting this new parabola that we are thinking about. So we already have the first one. Now we are starting the second one.
Why don't we call it
So what is the
start,
initial position for the
start.
second? Yeah, we already have position initial. So how about we have a position start variable? Isn't that great?
Yeah, whatever. Okay. And then another thing that now I gotta change this like 8 million ways. So when the position becomes 0, we want the position to stop going down further than that, right?
Yeah.
Okay. So again, like my brain goes to trigonometry where negatives like it becomes a circular thing, but I don't know, my brain may be in the wrong place.
No, it's much simpler than that. The ball is just hitting the desk. It's going to start bouncing back up. Now we are computing the position of this next bounce. what is the initial position for the second bounce? Where does the ball start? On the first bounce, exactly. On the first bounce, the ball started where you left it, position initial, which is a slider. On the second bounce, it's going to start at 0, the desk. So you can just say a 0 there, and that's all. Now for the velocity is not so simple because we have been computing the position this whole time. We don't know what the velocity is at this point. So how about we use the first flavor of the equations of motion to compute the velocity?
Sounds good. Velocity equals AT. So A is acceleration times underscore time plus velocity, right?
Plus velocity start, I think. Yeah, but you got it right.
Cool. But velocity start is
we do have to remember.
So now I need to go like this, like velocity equals velocity start, blah, blah, blah.
No. We are changing the notion of velocity start based on the previous velocity start. So velocity starts appear both on the left and the right of the equation.
Okay. So acceleration times underscore time plus velocity dot start. Oh, that's totally allowed. Okay.
Yeah. And there is a wrinkle. We do need to use the elasticity because this velocity that we have on the screen right now is the velocity with which the ball is hitting the desk. But it's going to lose some of that energy in terms of sound, so it bounces back times elasticity. So just put parens around the formula you currently have and multiply by elasticity, and we are good to go.
That's a thing of beauty. Reaps dupe elasticity. All right.
Yeah, and I think there is one more thing that we have to consider. So the next thing we have to consider is the time, because from the perspective of this next bounce, this next parabola that we are drawing, time is 0 again, right? The parabola started again. So for all the other equations that have to do with time, we don't want to move further and go into the negative abyss of minus infinity. No, we want to set the time back to 0. So you can say underscore time is equal to minus time step. The same way that we had a setup for time on the beginning of the loop, you can say that again there.
Okay.
Okay. Can we look at this?
We can. Everybody, are you ready? I said, are you ready? I can't hear you. Let's check it out. Okay, we got 1.
Really? Just that? That's underwhelming.
Well, okay, if we change the height, if we change the elasticity, if we change the... Whoa, that's cute. Huh? It's like drippy.
Yeah, because we don't have enough points to draw the thing.
Yeah, I'm gonna...
But it's not bouncing back.
I'm gonna just... Let's make sure of all the things we usually make sure of. Which one of which was that our code was updated. It was updated for sure. We said...
Yeah, it's still not bouncing back. I suspect that we are missing a minus somewhere because we do need to keep track of how, like, velocities and accelerations need to point in the right direction, right?
Yeah. So one thing I remember is, you know how we added this minus acceleration somewhere, not in our in GFX, we added it somewhere. Do you remember where it is?
We did put negative acceleration in a few places. I remember doing that.
So I remember last week us doing that and then having to change that later back to where it is. But for now, I guess, what if I make this minus acceleration time? Does that make sense? No, that doesn't.
Yeah.
Does that make sense?
Hang in there. This velocity start needs to be positive.
So
let's think about this for a moment. It needs to be positive because it's a vector that is pointing up. The velocity is a vector that is pointing up. So acceleration is a positive number. time is a positive number.
Velocity start.
And elasticity is also positive. So as far as I understand, velocity start should be a positive number. But on the right pane, we will find velocity start. Can we see what its current value is?
You fucking... It's 0.
It is positive.
Oh, well, yeah, if we count 0 as positive. Yeah.
No. Yeah, it's 0. So that's no good.
Well, that's because our velocity start is 0. And then what block are we doing this shit in? In the slider block. Should we not have this loop somewhere else? So that it begins to pop
No,
in?
it's fine. We are on the slider block. We have all the information we need to compute this. In fact, the first part of the parabola is right. It's just our simulation of the bounce is wrong in some way, and we have to think about what could be wrong.
Okay, I have another idea. So we said this loop kicks in when position is under 0, but our position is just 0. So we gotta like, I feel like we haven't gotten this thing started. So it's like, if that makes sense.
Well, that's a good point, and we can use a trick to check if a certain line has been evaluated. So in the position less than or equal to 0 question mark blah 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 block, inside the block, we can have something like debug plus equals 1, and then we will know if this block is even running, because you suspect that it's not, and I suspect that it is. So we'll see.
4668.
It is running, yeah. And then what else could be wrong? So position start is 0. That's our desk. That's fine. And position start is used to compute the next positions. That is okay. Then
square of time is 0. That sounds interesting.
But it's right though, isn't it? Not necessarily on everywhere, but remember that this loop ran and then it stopped. So time is whatever is the last value of time. In this loop, we are looking at the last one, and it's okay if time is equal to 0 in that situation. Yeah, the magic number is not being used in this loop. The random divider is not being used. Only the height and elasticity are being used in this loop. So that's not that. But yeah, scroll down. We'll stare at this for a bit longer and we'll figure it out. So we are resetting the position, and then the velocity, it should be positive. How is the velocity being used? It's multiplied by time. Yeah, and it's being multiplied by time.
Sorry, I'm just checking one thing here. Okay, yeah. Oh, time is curiously equal to our 5K resolution.
Oh, that's no accident. Remember, we are looking at the time where we last left it off. And we are running this loop that increments the time step 5120 times.
So to me, what seems to be the issue is that our position start and our velocity start don't change, but they should.
Yeah, but they aren't they? Because we have this, we just looked at these lines are executing.
Yeah. What if I remove this equal to? It has to be less than. If it's 0, leave it alone.
Okay, you can do that. I don't think it's going to affect anything, but
we got some
it doesn't
bounce.
hurt to try. Oh, it does affect something.
But the bounces are crazy. Let me put the magic number and stuff like that. Let's make them normal. Yeah, because I feel like when it stays at 0, it doesn't actually go to negative. That was my kind of theory. Oh, that doesn't even change. And then the height, it's a very interesting. Whoa, check it out, huh? That excited me that there was more.
It's very cool when things go wrong when you're doing graphics. It's always like
Like, yeah,
weird and
like
artistic and
what?
cool. But you can start to get a feel of what this is going to be to the user, right? You'll be able to slide and you see the bounces and imagine a waveform below.
Yeah,
It will be super cool.
exciting stuff. So I guess again, kind of let me know if I'm in the right ballpark. I feel like up to this point it's perfect. At this point, the values that are starting at the beginning that we keep wrapping back up are getting super negative, and so they are wrapped back up to be super duper positive to the point where they are like exceeding the height. You know what I mean? So we limited the below,
You
we
know,
limited the floor to be 0, but we need to also limit the top not to exceed like 2 meters, which is the height of our screen.
No, I don't think that's the case. We don't want to do any kind of limitation like that. I think that the issue is that maybe we are computing the start velocity wrong, and that's why it's bouncing back up too much. So maybe let's review this velocity start formula. It's the equation of motion number 1, where the final velocity is equal to the acceleration times the time.
Yeah.
And all of that seems okay, plus the initial velocity. And that may be wrong. Well, no, we are updating the initial velocity for the next time we go around. So that much seems correct.
Positions index, it's 1. Should it be 0? So that it starts at 0 when the first one is wrong, and then we update it, and on the first one it's right. Oh no, because we're adding 1 to it. Sorry, I'm dumb. Yeah. So it's -1, we're adding 1 to it. So on the 0th time, it's wrong, then we update it.
I don't understand that. Can you say it again?
So our positions index is -1. Loop starts at the first time that the loop starts, this becomes 0, and it's wrong until we get here and we change it, right?
No, positions index is unrelated to position start.
Oh, it's totally unrelated. Okay.
Yeah, positions index is an index into the positions array. So it's an index, while position start is in meters. That's our initial position for the bounce. So one thing is for sure, it's bouncing.
It's bouncing, baby.
Yeah. Yay. It is bouncing. But I think you are onto something. The position being less than 0 is kind of a hack, because what I'm saying is, if you are about to go below the desk, then bounce back. So, and it's never going to be 0 exactly, because it just doesn't work that way, right? So there is no guarantee that we are going to hit the desk exactly on the right time step. On the right frame, so to speak. Right. If we have a camera, the time step is our frame rate looking at the thing. And there's no guarantee that we'll get a frame exactly on the ball hitting the desk. Right. And so we are going to go below a little. And that's why I said less than or equal to 0. So it's going to go below the desk and we are going to recover real quick. But you are onto something. When you changed from less than or equal to less than, it started looking more correct. But maybe if we went below the desk too much, we don't recover in one frame, so to speak. So that hack is not necessarily going to work for us. So maybe what we can do is I think I'm going to propose another hack.
Love it.
But I think this, okay, yeah, I think this is going to be another hack, but it has a chance of working.
Okay.
So here's what I wanted to do. I want you to move the positions at array structure data, positions index equals position, all of that. I want you to move that below. So it's after the computation of position.
Cool. Zoop. And it needs to be one level
No,
back.
you are in a condition.
Oh, okay, sorry.
You are in a conditional, don't paste there.
Here.
There. Yes, that. So now what we are going to do is like this. We are going to compute the position as we are doing. Then we are checking, is the position below 0? Because if it is, then we are below the desk. That's a mistake. So let's now recompute the position to go above the desk, and then we start the position and move on.
Okay.
Okay? How about
Sounds
that?
good.
Okay, so now what we need is to have a line that essentially reads the same as the one calculating position. So position equals to position start, blah, blah, blah. All of that needs to be copy and pasted below. So that's why I'm saying it's kind of a huge hack. But it's above the previous line. It switched the last two lines.
Zoops.
I only want to start the position when it's actually correct.
Boops. Doops. Okay.
Yeah, and
do the whole thing. Full recompile reset.
Yeah, maybe do a full compile reset, and yeah, let's see if that changes anything. It changes a little bit. The wave changed a little bit.
Yeah.
But that's not all. I still want to do one more thing. I want to guarantee that we are going to go above the desk before we proceed.
Okay.
So let's have a while loop.
Okay, awesome. Yay, while loops. All right.
Yeah, so before the line that reads position equals blah, blah, blah on the hack, yeah, that line, let's have a while loop. You can say while position is less than 0.
Like this.
And then you need to put parentheses around the position in 0.
Okay. Is it?
And Callisto Pascual is on the chat. Hey, Callisto, and you're saying, when the velocity is updated, shouldn't the acceleration be reset to 0? I don't think so, because as far as I understand, the acceleration is always constant. It's 9.8 meters per second per second. The Earth is always exerting gravity over the ball. So I don't think we need to update the acceleration ever when you're modeling this. We are updating the velocity because the velocity is now pointing up.
Yeah.
We are never updating the acceleration. Right. Okay. So go ahead.
I guess for a moment, like when the ball is coming back up, like ball hits the floor, and based on its elasticity, it bounces back up. It's still being like a force of 9.8 is on it, but for a bit it's stronger than that until it goes hang time comes down, right? Yeah.
Yep.
Okay.
Yeah, so in that while loop, I want you to have the line that reads position equals. But then I want you to close parens after that line, because I don't want the line after that to be in the while loop.
Like this, and then put a
that.
Syntax here is correct. Looks wrong to me.
It is correct, but you do need a semicolon after the close parens on the while loop, on the line that reads position equals blah blah blah.
Oh, so
no, not that line. No, remove that semicolon and put one in the line below.
Here.
There.
So
that's the end of the while loop.
So for loop, we say for something do. For while loop, we just say while one thing, another thing.
Yes, while condition. Our condition is position is less than 0. We are below the desk. We are trying to fix that. And then you put parentheses, and you can have a series of expressions, or sorry, a series of lines, a series of statements. And all of them are going to be run. You are going to run the block, and then you're going to go back up and check the condition again. Am I above the desk now? No, I'm not. I'm going to try again. Am I above the desk now? No, I'm not. I'm going to try again. Okay, but we still are missing something. We need to advance the time. We need to move forward because we need to compute the position more and more into the future, trying to get above the desk. So in this while loop, you should also have a time plus equals time step, underscore time plus equals time step
on a new line,
situation
right?
going there.
Like,
yeah, on a new line, yes.
So time, or sorry, underscore time equals same thing as before, right? Like that.
No. It needs to be plus equals time step. You were trying to advance the clock so that it goes to a time where it's above the desk.
Gotcha. Blinks.
And save that. Let's see what that looks like.
Ooh, the bounce.
Okay.
But that's progress. There we go. The bounce looks like this now. So there's a time where when we go here, it loops back up, but it needs to like whooshed back up.
Yeah, it is weird, isn't it?
Yeah.
It is very weird how it's like choppy like this. It wasn't like this in
before 4 times.
Like a moment ago. So how about another hack?
Love hacks. Yeah.
Well, first of all, there is a problem. We are saying that underscore time is equal to minus time step. So this plus equals time step in the while loop needs to occur before we try to compute position, because trying to compute position with a negative time will not make us happy. So can you move the little line that reads underscore time plus equals time step before the calculation of the position?
Sure. So I'll go like whoops and doops.
Yeah, and let's look at that. Does it look any different?
Not. Let's, I guess, do the old droops. No.
Yeah, that's unfortunate. How about maybe the time step is too big for this recovery thing that we are trying to do? So where in the line that reads underscore time plus equals time step, say time step divided by 1,000 on the while loop.
On the
while loop.
Yes. Divided by 1,000.
Yeah, divided by 1,000. This is gonna make us try to progress the clock very little. So we try to get that initial part of the bounce. And that doesn't change anything. So I'm at loss. I don't know.
Very interesting. So I guess like what's clear, okay, so I think you fixed one thing really importantly, which is soon as we hit the floor, like advanced time, right? But there's a jump here. We need to bridge that, whereas before it was. So the reason it was working before, I'm trying to understand, is that this was going down and then kept going down all the way to like below my screen. And at that point, we grabbed it, we sent it back up. Then it got kind of nuts. It went all the way up there. So it looks like this. But when we did this, we did a while loop. While position? No, I'm lost, man. I'm lost.
Yeah, this is very weird. I don't know exactly what is wrong here, but I do think that this is a good time for us to wrap up. I mean, we do have some shape on the screen. It doesn't look exactly like the thing we should have on the screen, but it does look like something. And next week, we can even try to draw the waveforms. And you can send me the code and I will try to find what is wrong, and you can look at the code and try to find out it's wrong, and everyone who's watching can look at the code and try to find what is wrong, but I don't know what is wrong. Cool. I will have to play around with this for more time.
Do you want me to send this to you, or do you want to just look at it on the stream?
Oh, I would prefer if you could like put it on GitHub or something. You do have a GitHub repository for your ReaFIR things, so just put it there and I can check it there.
There's actually something wrong with my GitHub repository that I was hoping one day you would help me with. What is that gist thing that you did once? Can I do that?
You can do that. Yes, just go to gist.github.com or gist. Gist?
I thought it's like the gist of the code.
Yeah, it is a very lightweight repository that you're creating. That's what it is.
Shabloinks. This is...
And you can put that in the video description for everyone.
Shabloinks. And then I just save it and then I go, whoa. Do I need to say no? I'm using Command and S like an idiot. I go create public gist, hit it. This is the code, right? This is the link I need to share, or raw?
Yeah. No, not raw.
Shabloinks. I'm putting it in the chat for you. And I will put it in the description of the video. Yeah, we're gonna resume next week. I was gonna do another stream today. I was gonna like have lunch and then do another stream. I may not because I don't know. I'm very short on time, so I may instead record a video today. Nobody watches my goddamn streams anyway, so we'll see, everybody. I may show up in like half an hour doing another stream of mixing, and maybe not. Maybe I will, maybe I won't.
It's a mystery. But we do see you on Wednesday on my channel, am I right?
Yes, absolutely. And we are going to get started on orchestral action.
Yes. The plan for that is that I know nothing about orchestration and I have an orchestral library. And we are going to play around with that, starting from the composition. I don't have anything.
Mm-hmm. Cool.
Yeah. And Callisto has a lead. Looks like the point after the bounce is restarting at half of the wave height, maybe.
Oh, beautiful.
Maybe. I don't know. It could be an issue, yeah. I don't know. It's so weird. I have no idea. I'm going to look it up and we'll see. Next week we'll have a solution or not for this.
Yeah, the code is in the description as well. But yeah, let's have a look at that. I'm going to make this big again so their first ones are big. Yeah, that now it makes sense. I guess Leandro also as a feature request. Since our height is limited to like 2 meters, it'd be nice if we could have some lines here.
Oh yeah.
Yeah.
Labels on the axis saying what the heights are. Yeah.
And labels on the axes. Is the plural of axes same like I know it's different pronunciations, it's same spelling. I'm not sure. That's for all of y'all to find out.
I don't know. But another thing that is super weird about this is that it's getting louder, right? I mean, it's going higher up. That doesn't make any sense.
Yeah. I mean, our sound isn't, but yeah, whatever we're doing on the GFX block, it's still detached from reality.
It is. That's not good. All right, so I see you again on Wednesday on my channel. And for people who are here and are interested in programming, I have something that we may do tomorrow that I think is interesting, Arya. What do you think about this? So I'm working on this JSFX library, and I'm going to return to it. But I thought we could do an intermission that could be kind of fun. So today I picked up an Arduino.
Cool.
I picked up some soldering iron and a multimeter and some buttons.
Nice.
And an expression pedal. And I thought, wouldn't it be fun to do some hardware together? We could do a MIDI controller with some buttons that would send MIDI signals and an expression pedal. Wouldn't that be fun?
That'd be awesome. You should talk to John about that, because John does some hardware stuff. So A, he would have expertise, and B, Maybe it'd be like this. Well, I don't know what John is up to, so I shouldn't say that. But maybe he'd join you or something. That could be fun.
Yeah. So I guess that's what I'm doing tomorrow on my channel. Just wanted to plug that because I think it would be fun for people who are this deep into programming for audio, doing something that is related. It's still a MIDI controller is still related to audio, but it's hardware, so it's gonna be fun.
Can I actually, since we're on the subject, real quick, I want to pitch an idea that I have for you, and you tell me if it's dumb or if it's smart. It's probably dumb. Okay, so this device is a hardware device, and its input is an XLR. But it is not a speaker, but it does what a speaker does. So a speaker takes -1 to +1, changes it into voltage, moves some speaker cones, right? And gets that movement data from digital audio. I want the device not to move a speaker cone, but move a physical thing up and down. So you can write with an LFO a picking pattern that goes boop, 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 something like that. And then you take that device, you put it in front of a guitar, and it strums it for you. So it's using digital audio, but it can strum at a speed of like 3,000 strums per second because it's a physical thing that's moving. You know what I mean? And then what would a guitar sound like if you play a chord, but you pick it 3,000 times? The chord becomes the wave form, but the frequency will be 3,000. So it will be a pitch, but you create these. So you're like bringing these insane numbers into digital reality. And of course, like air resistance and all that stuff will have an effect on it. But does that make sense to you so far of this conceptualization?
Yeah, I mean, what you're proposing is effectively like well, there is a limitation there, and that's physics and reality and attraction, all those forces that make us unhappy, right? It's very hard to move a pick 3,000 times a second.
So well, how do they do it with the speaker cone?
Well, a speaker cone is, the travel of the speaker cone is very small. It's not pushing a lot of air.
Oh,
it's moving around, but it's moving around only a little bit. And you're proposing something that would move a lot more and that would hold more weight too.
Yeah. Well, what if it was smaller?
So maybe, maybe you wouldn't be able to pick all 6 strings on a guitar, but maybe you would be able to pick 1 string on a guitar, maybe not 3,000 times a second, but something like 200 times a second.
That's still crazy, right? Yeah.
I think that at some point it's going to sound like a bow.
Exactly. Yeah.
If you think about it, a bow is moving on the string, so the bow is kind of, so it drags the string for the slightest bit, and then the coefficient of attrition becomes too great because of the tension of the string, so it snaps back, and then it moves ever so slightly a little bit more, and then it snaps back. So it is like a peaking pattern, but a very fast one, I think.
And I mean, like, I guess the main thing that I'm thinking with this is not necessarily to pick like super fast, but I mean, imagine instead of recording audio, quantizing it, you quantize something. So I can hold my guitar and I can hold the chord shape, and the picking will be perfect because I have created these like little clicks. And but it's controlled by an XLR, so it's not like a whole new output and a bunch of other bullshit. It's just a thing that moves. So I can have it like have a pattern of like tap tap da up 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 da up, and then I just kind of changed it. So it's kind of like bringing quantization back into the real life without like reamping. It's like preamping, but that's a
yeah.
That's an idea.
That's something cool. I mean, it has motors involved. It is moving things around. So it's not going to be my first project. Yeah. This is also not this project is not my first project, but sensors are always easier to work with.
Yeah.
Because you just read the data. When you have to actually put the data out into the world, all sorts of things need to go right. You need to have the right values in the right range for everything to work correctly. But That could be a nice second project.
Cool. Well, when you made the stream, like the schedule, or you may have already done it, let me know. I can make a community post for the 3 people who read my community posts to come check you out, because I'll be at work. Unfortunately, I've been missing all the Tuesday and Thursday streams, and then I show up on Friday kind of confused.
Yeah, but that's it. Tomorrow at 6:30 UTC, I will be doing a MIDI controller. It's going to be a pedal board kind of thing, and it is going to be using Arduino, and we'll do it from scratch on the stream tomorrow at 6:30.
Yeah. Calixa say we all know you will end with a hardware version of bouncing delay after all. Yeah, it just drops things on the floor. Oh,
Yeah, we could drop the ball, we could detect the transients, and that would be setting the taps instead of us having to painstakingly go to Wikipedia, come up with all the equations, and do all the mathematics. We could just read the data from audio.
Bo says it will be more efficient to use a magnet to excite. I mean, I already have a magnet that excites the strings rather than a mechanical device. The point is, that was just one example of things. Like, the point is, like, you can have a fully quantized LFO that you can use to manipulate real life objects with. That doesn't have to be a string. It can be drums. I can put a stick on the thing and then it goes beep, 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 beep. I don't know. That's just what I was thinking. But yeah.
Yeah, I think there exists MIDI, not MIDI drums. There are real drum sets, acoustic drum sets that you can control with MIDI, and there is a little robot that plays. I think that's a thing.
Yes, and the piano version of it is a thing. And actually, even before digital technology, there was a mechanical version of those things, which I forget what they're called, but it's like a self-playing piano, which is really awesome. I love all that stuff. But let's get out of here. Somebody just showed up on the stream. Haha. You snooze, you lose. All right. See ya later, everybody.
Bye.
Nope. Thanks for watching is on the screen now. There we go. And I can end stream right there.